Hey, physics class. Just a quick video because class ended. Kind of got carried away a little bit last class and didn't get to something I wanted to get to make sure we had, make sure we could do the homework. And I wanted to test out some new toys on my laptop. So, what we didn't get to is how to break up weight when you've got something like you're sitting on an inclined plane. So I wanted to take a look at question number 3. Uh, Probably won't do the whole thing for you, but I do want to show you how I would attack this problem. So question number 3, a block is sliding down the plane and there's an angle. If obviously if you just drop something, gravity will accelerate it at 9.8 meters per second squared. But when you're on a plane, it's going to be something less than that. I want to figure out how to do that. What I'm going to do is I'm going to draw myself a free body diagram. So here's my version of that inclined plane, and here's my block. My block is sitting on the plane, and I want to know what forces are acting on that thing. It's frictionless, so there's really just two. There's weight, which is going to be straight down. Weight of the block is going to be straight down. Gravity pulls straight down. And then there's going to be the normal force. Normal is always at a right angle. So these are the two forces acting on my block. It's going to accelerate down the plane. And so the coordinate system I'm going to use is actually this coordinate system. I'm going to turn my coordinate system so everything is kind of at an angle. And so the normal force is directly in the y direction, but the weight is neither purely x or purely y. So I want to break it up. That's always my motivation when I'm dealing with vectors. I want them to be either in one of my either directly in the x or directly in the y. So let's see. Where's my? Oops. I want to. Pardon me. While I want to. Where's my toolbar for my pen? I want to change colors. So let's go to. Oh, this is too complicated, but whatever. This is too much work. Just to change pen colors. Come on. All right, there we go. So I'm going to chop up my weight into two vectors, that way and that way. And so remember, when you chop up a vector, the vector you're chopping up becomes the hypotenuse, and the legs become two orthogonal components. And you can see that those are in my coordinate system. And so I might call this wx and wy, where this downward vector is w, and theta is there. Now, how did I know that's where theta is? A couple ways to do it. If you remember some geometry, you can draw yourself a similar triangle. So if I take an arrow here and then and I turn it into a right angle there, this angle here is theta. This alpha becomes what? The complement of that, and that makes this theta here because that's also the complement of alpha. So, and this is a right angle, and this is a right angle. So I don't know if you remember that from geometry. So that's one way to do it. Honestly, the way I do it is I just imagine if theta were really small, what angle in my triangle would also become small, and that's usually how I figured out. Either way you want to do it. So I'm going to break up my weight vector, and now I know everything. I can actually figure everything I need to know about this problem. I now know that because this thing is not accelerating away from or into the ramp, it's staying stationary in the y direction. I know that the sum of the forces in the y direction are 0, and that is normal minus wy, or another way to say that would be normal equals wy, and looking at my triangle, that is w cosine theta, because that wy is the adjacent leg, and the wx is w sine theta. And so now I actually know the force that is acting on this block in that direction, down the ramp, and from that I can find the acceleration. In fact, yeah, I could even use that same process to break up the acceleration vector, because I don't know the mass of this thing. It'll cancel out. So I could say the acceleration of this thing, a equals f over m. The acceleration in the x direction is mg sine theta over mass, and the mass is canceled out. Oh, I just did it for you. So there it is. Anyway, Hope that's helpful, and I'll see you guys Tuesday.